Welcome to Rges Algebra 2. This is lesson 24B, and we are finishing up chapter 7 today on powers and roots. So you did for your homework a check for progress. This is the homework due Monday. You were assigned a check for progress and a check for improvement. So there's no new instructions to focus on, but I am going to do a review and then a preview of the next section. So my review will go ahead and cover 7.1 through 7.7. I think a couple of these sections are skipped, but I'll make sure to clarify that as we get to them. Now our first section has to do with powers. Powers are when we are doing the operation that raises a number or a variable to an exponent. So if we have 2 to the 5th power, that simply means 2 times 2, this is all review, times 2 times 2 times 2. If we had a negative 2 to the 5th power, don't forget if that's within the parenthesis, you need to deal with raising that negative sign also. So if we're raising to an even power, like to the 4th power, a negative sign, then our answer will be positive. And if we have an odd power like we do here, and we have a negative sign, then our answer will be negative. So just deal with that at the beginning so you don't get confused or forget. That's what I like to do. A couple of things you do want to remember as basic rules. Anything to the first power is itself. So x to the first power, or 7 to the first power, 7 to the first power equals 7, x to the first power equals x. Okay. If you have anything to the 0 power, that equals 1. So if we have 7 to the 0 power, that would be 1. And if we had y to the 0 power, that would be 1. Okay, not y. Y to the first power would be y. So be careful with those. By the same token, if we have 1 to any power, 1 to the 27th power, that would be 1. If we have 0 to the any power, 0 to the 7th power would be 0. So these are 4 good things to memorize. Okay. Other than that, it's very simple. If you have a number to a power, you're going to have to think back like we did with 2 to the 5th power, and we're just going to have to multiply it out if we don't know it. But if we have a variable to a power, whether that be a negative power or a positive power, let's say we're raising all this to the 7th power, we are going to multiply. So that's going to be x to the 14th, y to the negative 5 times 7 is negative 35th. Now recall a negative power would drop it into the denominator, so that is the same, synonymous with x to the 14th over changing that. We can change the exponent to negative or positive by moving it across the division line. So this would be a positive power of 35 if we moved it into the denominator. Those cannot simplify because they have different variables. And so you do want to glance over 7.1, but we have been doing quite a bit of practice over it recently. We've also done it with it in the denominator. We've also done it, for instance, just reviewing a couple more ideas. What if we had x to the 2n power raised to the 5th power? We're simply going to multiply just like we did before, and that becomes x. Our basic operation is the same. 2 times 5 is 10n. Okay. So should be pretty clear there. In 7.2, we have done a lot of review on this. This is our binomial theorem. And since you guys do seem to have a good grasp of this, don't forget whether it's whether it's a negative or a positive. If we have a negative, we have to change every other sign, beginning with the first sign in front of the second term. If we have a positive, they'll all be positive. If I have this, let's say, to the fourth power, that should look like a 4. We're going to say x to the fourth. We're going to take a subtraction sign. We're going to find our numerical coefficient by taking the number in front here, which always begins with a 1, right? Because 1 times, it's not a 0, right? So maybe I need to not make it look like a 0. Okay, I'm talking about my numerical coefficient, and if I have nothing in front of x to the fourth, that is the same as 1 times x to the fourth. So we're going to take that 1 times 4 times the number of the term. This is the first term, and we'll get 4. Our x's will go down 1 each time. Our y's will go up 1 each time. The next sign will be alternating. We're going to get 4 times 3. We are on our second term. We're going to divide, and we'll get 6. X squared, y squared. X's go down and y's go up. And I'm actually very familiar. I'll finish it out, but I really do think that all of you have mastered this by now. We have 6 times 2. We are in our third term, so that would be 4. And we're going to have the opposite sign. We're going to have x's go down and y's go up. And finally, my last term will have no x's, so only y's, and the y's will go up. And there's my answer, just like that. And you all have shown yourself proficient, so we're just reviewing. Now, what happens if I want just a specific term? Like, let's say I want to do that one again. I have x minus y to the let's say to the 7th power this time, and I want the 4th term. And I don't want to write them all out. What would I do? Well, I'm going to think 1 less than this, so I'm thinking 3. I'm worried about my 3, and I'm worried about my power. And everything's going to be derived from there. The first thing I'm going to do is identify the 3, 1 down from the 4th term. So I'm going to identify that 3 as my exponent for the y term. I'm going to identify my exponent for the x term as whatever I would add to 3 to get the exponent. So to get the 7, I would have to add that. If the 3 is odd or even is what you're worried about next. Okay, so it's going to be odd, my 3 is. So this will be, because this is odd here, the new number we're thinking about, because that's odd, then it will be negative. Whoops, about leaving myself a little room. And now all I have to worry about is the numerical coefficient. I'm going to take my exponent, my 7, and I'm going to use 3 terms, the same number here. So 7 times 6 times 5, part of the factorial, and 1 times, get rid of that funny look, 1 times 2 times 3. Well, 2 and 3 go into 6, and we're going to get 35. So this is my answer. And again, you all have shown yourself in this class very proficient in that, and I'm very proud of you for being able to do that. So that would be 7.3. 7.4 talks about roots, and so if we're taking the square root or the cubed root, recall that if I had an exponent and I had broken it down to its primes, and let's say I had 2 squared times 3 to the 3rd times 5 times 7 to the 9th, let's say. And then on my variables, I would have x squared, y to the, they don't do that in this, y to the 6th, and z to the 10th, let's say. What do I do? If this is a squared term, so it's going to be an index of 2. I'm going to take that as my divisor. And everything that goes in evenly, let me change a couple of these since I don't want to do more than they do. Here, hang on a second. So I'm going to divide every exponent by the 2. 2 divided by 2 is 1, 2. So I'm thinking an exponent like that. 2 to the first. I'm taking the same root. The root in the next one, or the base, I'm sorry, is 3. 6 divided by 2 is 3. 5 is my base. 16 divided by 2 is 8. 7 is my base. 4 divided by 2 is 2. Notice it doesn't change. When I move from letters to numbers here, the same basic idea applies. X is my base. 2 divided by 2 is 1, so I could have just written X. Y is my base. 6 divided by 2 is 3. And Z is my base. 10 divided by 2 is 5. And that's the answer, except that I would expand that, which I don't have any intention of doing because I would take out a calculator to do that. But it would be 3 to the third is 27, and this would be a 49, this would be a 27. Notice how I'm avoiding 5 to the 8th, and this would be a 2, and my calculator would get me the rest of that and multiply it out, okay, with a calculator. And then we leave this the same. We don't have to put the to the first power. And again, this is a review, so you've seen this before. If I had a negative under here, I would have an imaginary, so I can't do that. But if I had cubed roots, okay, then when I expand this by prime factoring, I would get 3 to the third, let's say it was something a little more not so overwhelming, and 5 to the 6th power, and x to the 9th power, and y to the 27th power. And let's go ahead and throw in a negative sign. So in odd roots with an odd index here, we could have a negative. So that because a negative times a negative times a negative, when I multiply it back, would equal negative. So odd ones work, even ones do not. And my base is 3. 3 divided by 3 is 1. My base is 5. 6 divided by 3 is 2. My base is x. 9 divided by 3 is 3. And my base is y. 27 divided by 3 is 9. Go ahead and expand the number part. This would be 25 times 3, or minus 75 x cubed y to the 9th. Sometimes if you have a fraction and you have numbers under a fraction, under a radical sign, so a square root or a cubed root, you could maybe go ahead and simplify first. I would simplify what's under the radical first. So if I had something like this, usually these work out better when you go ahead and do your division underneath the radical before you take out your square root, or before you do the square root operation. So 16 divided by 4 is 4. The x to the 7th over x is x to the 6th. And y to the 9th over y is y to the 8th. And now, notice I had not dealt with the square root at all. I just simplified what was underneath the radical. So you simplify what's underneath first. Usually it works out better this way. Sometimes you'll find it works out better the other way. So you can play with that a little bit. Be alert to that. And this would be 2x cubed y to the 4th. On 7.5, you're going to skip 7.5 as you're preparing for the test. 7.6 is when we do the binomial factoring. So I kind of summarize that in with the first 4 lessons. So 7.6 was part of the explanation we just gave. 7.7, I'm not going to worry about the calculator portion of this, but we did practice it a little bit, just so you could get familiar with your own calculator. So 7.7, we're going to skip all the way down, start at the Pythagorean theorem, number 23. And you did those, and we went over those not very long ago, so I'm not going to review that again, but we cared that you would be able to do 23 to 28, and we did not have to cover that very much in class. Now, then you're on to the check for progress. So let me look a little bit at the word problems and then a new idea. So I have listed the problems with a star here, these 1, 2, 3, 4, 5 pages. These are the problems I expect you to be responsible for. So I stepped away a minute. I apologize for that. What we're looking at with these word problems is these are the ones here that I want you to be able to do those problems or something that would look very similar to those problems. Focus your attention there. Skip these word problems because I don't recall teaching those to you yet. And so we will cover those when we're in chapter 8. I'll come back and grab those because I also do not think that those are too difficult for you. So that should be a good review of chapter 7. You will be having the test on chapter 7, I believe. Next time, let me see. Yes, it will be both chapter 6 and chapter 7 next Wednesday. Chapter 6 and 7. Now stay online here, so we're going to go ahead and give you a preview for 8.1. Now looking at 8.1, go ahead and read through this section before you get to the problems. Most everything in there we have reviewed except for the last 2 ideas. But I want you to go ahead and look at that again. Now here is one of your new ideas, and this says, what if you have a base raised to a power that is a fraction with both a numerator and a denominator in it? So what do I do with that? Okay, so I'm going to, the top number is going to be my power, and the bottom number is going to be the root. So this represents 8 to the 5th power, and then we're going to take the cubed root of it. Or we're going to take the cubed root of it and then raise that to the 5th power. Either way, the numerator is always the power, the denominator is always the root. Now, one of these will be simpler to solve than the other. Can you identify which? If I took the cubed root of 8, I know that's 2, and 2 to the 5th power is 32. If I did it the other way, I would have to take the 5th power of 8, so I would have 8 times 8 times 8 times 8 times 8. Hardly matters if you're doing a calculator, but if I'm trying to take the cubed root of that, well, let's see, I'm going to have that to pull out, and then I still have the cubed root of 8 times 8, or 64, and I still, what times itself? 4, okay? Times 4 is 16, times 4 is 64, so the cubed root of 64 is 4. And now that is, I'm sorry, that's not a 4. 4, and 8 times 4 is 32. So you're going to get the same answer either way, but some are going to be a little easier path for you to do it mentally. Okay, so that's a new key idea here. This right here. Now here's another example. 8 to the negative 4/3. Okay. Well, again, I like taking the cubed root of 8 because that's simple to me. So this will be, but now the negative says that it's going to be in the denominator. So this will be the cubed root of 8, and then take that to the 4th power. That's the same. Notice I don't have a negative sign anywhere here. This negative means go to the denominator with a positive. Right? And so now we're going to do the cubed root of 8 is 2, and 2 to the 4th power is 4 times 4, or 1/16. And again, one of the things that you'll find easier is to play around a little bit with order. Which do I think is going to work out smoother in this particular example? Let me do you a couple more. Recall the bottom number is my root, so this will be 27 to the cubed root, because that works out nice and smoothly, and then I'll raise it to the power. Again, order does not matter, except for the smoothness or ease of operation. 3 times 3 times 3 is 27, so the cubed root of 27 is 3, and square it, and I'm going to get 9. If I were to do this just with variables, a to the negative p over q, I'm going to now apply my negative to this, and this will be the same as 1 over a to the p over q. Whoa, that's not a p. To the p over q. Okay. Recall what that means. It'd be a to the p power, and take the q root of it, but normally as we're doing this without numbers and just variables, that's a p. This would be a very good answer for that. Okay, so I'm looking ahead here. Now, as you're doing 8.1, you do want to pay a lot of attention to the directions for each grouping. Sometimes you will want to write it without a denominator, so you'll move it across the divisor line to the numerator with now a negative exponent if it were positive in the denominator. Sometimes you'll have to write in terms of decimals and sometimes in terms of fractions. If you're simplifying a polynomial, you'll want to write them all out in the same type format probably. Just whatever the directions would indicate. Now, I do want to show you a few examples. We've already done one like, let's see, I'm finding something that might be a little odd. Here we go. This is a good one. 15 and 5/8, all raised to the negative 2/3. So how would I do something a little complicated like that? So the first thing I'll do is convert this to an improper fraction. This will be 8 times 15 plus 5 more. That's going to be 125/8 to the negative 2/3. Negative's going to mean I'm going to flip that to 8 over 125, all to the 2/3. Both of these are cubed roots, so that will be the same as the cubed root of 8 over the cubed root of 125, and then I'm going to square my answer. I hope you're following each of these steps. The cubed root of 8 is 2. The cubed root of 125 is 5. 5 times 5 is 25, times 5 is 125, and then I'm going to square my answer. The numerator squared will be 4, the denominator squared will be 25, and that's how you do it. Okay, so you're just going to ease your way through it one step at a time, based upon your definitions. Let's look at one more here together. Okay, so for 58, it says we want to express this with radical signs. So I want the radical, the root sign there, and I want positive exponents. So I'll need to convert this to a positive exponent. Okay. So I'm going to put it in the denominator. Okay. And then I'm going to express this still in the numerator. And I'm going to now change to a radical sign and power. So this is a squared. Notice they both are under the third radical, so we'll just put them both under the third radical. A squared there, and then we're going to have over, I should have put it that way, but this way. Whoops, get an eraser, there we go. So it'll be in the denominator now because of this negative. I'll put my b in the denominator, and it's going to be to the fourth power, and we're taking the cubed root of that also. So notice this, I could have written this as the cubed root of a squared over the cubed root of b to the fourth, but then to simplify that, we could write it this way, okay, with one radical sign and the denominator inside the radical sign. And that should be able to give you enough help to get you going there.